we can see some similarity between this the structure of lignin and the polymer structure. But in this case, we can speak about biopolymer and not polymer. Okay. Now, what about the waste of vegetal oil, which is in after cleanup? Mostly the bio oil, it's transformed or converted to biodiesel. Why? Because it's or this method is economical, showed economical viability, which is very assessed. But in this project, we will try to find new ways to valorize this waste vegetal oil. The waste of vegetal oil we used is coming from GECO, our partner. Normally, GECO collect this waste from restaurants in north of France and convert it to biodiesel. In order to promote a new application of this bio waste, we will try to find a new valorization of this bio waste, for example, in the root, as you can see here, but also continue. But also in concrete, as you can see, in order to develop new concrete materials with low CO2 emission. By introduction of lignin and vegetable oil in concrete, we can develop a new bio-based or green concrete to manufacture not only some wall but also some insulate, some for example panel for insulation. Here you can see some segmentation of by region of the global lignin market. Based on this figure, we can see that Europe is the second important market of lignin after Asia Pacific. This is this figures show also that the disponibility or availability of lignin in Europe it's very important, and with this project we try to valorize it in different application. In order to conduct this development, some specific step must be respected, such as the choice of different materials coming from different sources. In addition, we have to develop a new process for production to choose what kind of analysis and characterization technique we use, but also to carry out or develop new tests of bioasphalt and bioconcrete. Of course, with collaboration with some designer, we look for valorization of this new bio-based development to propose new design of different products, but also to study the impact, the environmental impact of the new bio-based compared to classical asphalt and concrete. Based of this development, we also look forward to extend or to propose this development to a new company in our region. In order to give you some example of previous valorization, for example, in route, here we can see, for example, a road section made of bio-asphalt with a plant-based lignin binding agent, which after a CO2 reduction in road building. It's developed in Vlissingen in Netherlands. This project is commissioned by North Sea Port contractor H4A, which has constructed a sustainable route in this region, of which the bottom layer, the intermediate, but also the top layer of all consist of bio-based asphalt from lignin. A second example for valorization of lignin is developed by in Delfzijl by a chemical company Avantium, which announced production of bio-based asphalt in which fossil bitumen is replaced with lignin, but also allowing for a significant reduction of in the carbon footprint of route construction. As I indicated before, simultaneously to this development, in collaboration with some French designer and partner for Belgium, some development or design is undertaken and studying. For example, we already propose to create 8 parking space by introducing lignin and the vegetable oil waste. In addition to this realization, we are also trying to carry out with the designer some tests in order to develop or to valorize new bio-based asphalt in and concrete or vegetable concrete in furniture. In order to show to you this aspect of design, we will share with you a video coming from our colleague designer.
Lignin, a byproduct of the paper industry, is mostly burned for energy, even though this abundant biopolymer has strong potential for alternative uses. Sharing structural similarities with bitumen, lignin can interact effectively with used cooking oils, another widely available resource typically recycled into biodiesel. When combined, lignin provides rigidity, while used oil adds flexibility, creating a more balanced material suitable for bituminous mixtures. Early tests on blends containing around 30% lignin and 3% used oil show performance compatible with certain road applications, suggesting a promising bio-based alternative at a time when bitumen costs continue to rise. Developed by IMT Nord Europe and CEREMA within the European project Building Based Biobased, the material aims to reduce reliance on bitumen in asphalt and lower the carbon footprint of road surfaces. Designers Thomas Naville and Soumaya Nader experimented with this material by exploring viscosity, gloss, and solidification through tubular forms. The first tests demonstrate how this composite made from lignin, bitumen, and recycled cooking oil can also be shaped into objects and furniture. Their prototypes highlight the intrinsic qualities of bitumen, its density, flexibility, and sense of movement, while introducing a new visual language that contrasts deep black surfaces with a pale cement-like base. By transforming a substance usually buried beneath our feet into sculptural totem-like objects, these experiments encourage us to reconsider the presence and texture of a material covering nearly 60% of urban surfaces.
So thank you, Hassan, for your presentation, and hello, everyone. So this part of the webinar focus on some utilization of the lignin and waste vegetable oils. So we will focus on evaluating the impact of lignin and waste vegetable oils on cementitious material properties. We structured this work around three main axes. So the first axis is about investigating the impact of lignin and waste vegetable oils on the hydration, workability, and compressive strength of the past cement pass. The second axis is about looking further and doing more investigation in deep in order to understand the effects on these properties by doing some microstructural analysis like XRD, TGA, and doing more porosity also to evaluate the porosity of the cement pass in order to see the link between the effects on the hydration and the mechanical performances. And the last and the final axis is about concrete. So we will extend this study to the concrete scale in order to see how can we incorporate these two additives for a real application, and then evaluate this concrete based on these additives. So evaluate their workability, their compressive strength, the durability of this concrete, and also the thermal conductivity. So in order to see the limits of this incorporation of these additives, and also to see the reuse potential of these additives in reality. So our preliminary study is about defining a realistic range of dosage of these two additives. So to assess the impact of lignin and waste vegetable oils on the early hydration of cement, so we performed an isothermal calorimetry test